Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 11.3, Solving Radicals Equations, Day 1. So when we say we want to solve, it means we want to get our x by itself, get a final answer of x. Okay? So the idea behind this is we want to isolate our square root. So you'll notice that on the first step, what they ended up doing is they added 5 to both sides. So 3 plus 5 is 8. It gets us our square root by itself. Now, what we have always done when we're manipulating equations is to get rid of something. In this case, we want to get rid of the square root. We have to do the opposite. Well, the opposite of a square root is to square it. So if I square a square root, the square and the square root cancel, and it leads me just to x. Now the 8 gets squared, which turns into 64, and we are done. So that is what we are doing today. The first step is to isolate the square root. So in example A, I'm going to go ahead and subtract 7 from both sides. That leaves me with the square root of x equals 5. Now to get rid of the square root, I have to square it. Anything I do to one side, I must also do to the other side. Now when I square a square root, the square root and the squared cancel, leave me with x equals 5 squared is 25. Okay? Same thing on B. Need to go ahead and move this negative 4. So I'm going to add 4 to both sides. Leaves me with the square root of x equals 9. I'm going to square both sides. So x would equal 81. Now C, I start out with the square root already isolated. It's already by itself. So the first step on this problem is I'm going to go ahead and square both sides. Leaves me with x minus 3 equals 16. I'm going to add the 3 to both sides. So x would equal 19. Okay? Okay, now we're going to keep going. Again, D is the same idea. I already have a perfect square, so I'm going to square both sides. X minus 2 equals 36. If I add 2, x equals 38. Now E, I have a couple things I need to do to isolate the square root. I want to get that square root of x by itself first. So I'm just looking at the left side of the equation. What is furthest away from the square root of x? Well, it's going to be this positive 9. So what I want to do is move the positive 9 first. I'll subtract 9 from both sides. So I end up with 2 times the square root of x equals 6. Then I can divide by 2. The square root of x would equal 3. At this point, I need to square both sides, so x would equal 9. On to F. F again, I need to move something first. I want to get the square root of 3x by itself. I want to get the whole square root by itself. So I'm going to subtract the 8 to start with. The square root of 3x would equal negative 6. If I square both sides, now remember, when I square that, I'm actually squaring the whole negative 6. Okay? So on the left-hand side, the square root of 3x squared ends up being just 3x. And this would equal negative 6 squared ends up being positive 36. If I divide both sides by 3, x would equal 12. All right? Now G looks a little bit different. It looks a little bit different, however, it's not any more difficult. The reason why it's not any more difficult is our first rule every single time on these problems is to get the square root by itself. Well, as you'll notice on the left-hand side, the square root is already by itself. I already have all on G, H, and J. All these problems, I already have the square root by themselves. So what I'm going to do is just square both sides. What that does for me is it just cancels out the square roots. So I'm left with 3x plus 4 equals 5x minus 6. Now, this is two-step equations, which we have done a long time before now. I want to move these smaller variables, so I'm going to subtract the 3x from both sides. I want to get all of the x's on one side and all of the numbers on the other side. So to move all the numbers to the left, since I'm moving the x's to the right, I'm going to add 6 to both sides. So 4 plus 6 is 10. It equals 5x minus 3x is 2x. I can divide by 2. X then would equal 5. Okay? Moving on to h, it's exactly the same idea. I already have both sides. I have the square root isolated, so I'm just going to go ahead and square both sides, which just cancels out the square roots on both sides. So I end up with 2x plus 3 equals 3x minus 4. Again, I want to move the smaller variable, so I'm going to subtract the 2x from both sides. If I'm moving the x's to the right, I need to move the numbers to the left. So 3 plus 4 is 7. 3x minus 2x is x. And I'm done. J again is the same thing, so I'm going to square both sides. 3x minus 2 equals x plus 6. Move the smaller variable, so I'm going to subtract the x from both sides. 3x minus x is 2x. If I'm moving the x's to the left, I want to move my numbers to the right, so I'll add 2. 6 plus 2 is 8. Divided by 2, x equals 4. That is solving radical equations. If you have any questions on that portion of this assignment, please make sure you let me know. Come in before school, come in early before class, ask me while I'm at the board, whatever you need to do. Just make sure you get some help if you are confused by any of that. Okay? Let's go ahead and move on to the back real quick. On the back, we have some formula work. It says roller coasters. On a roller coaster ride, your speed in a loop depends on the height of the hill you have just come down and the radius of the loop in feet. The equation v equals 8 times the square root of h minus 2r gives the velocity v, so v is velocity, in feet per second of a car at the top of the loop. The h is going to be our height, the r is going to be our radius. Okay? You design a roller coaster with a loop that has a 36-foot diameter. Now, diameter, d, is equal to 2r. So if you look at our equation, I have 2r already. That means that I can just take this 36 foot and put it in for 2r. Okay? You want a car to have a velocity of 30 feet per second. So velocity is v. So I'm going to take the 30 and put it in for v. Let's go ahead and start plugging our numbers in. So I end up with 30 equals 8 times the square root of. The one thing we don't know, and it even asks us this, is how high should the hill be. So I'm going to leave h as h minus our 2r, which is our diameter, is 36. So what I need to do here is I need to isolate my square root in order to get to that h. I have to solve for that h. So the first step to this is I'm going to go ahead and divide both sides by 8. I'm going to divide both sides by 8. So I take 30 and divide it by 8. I end up with 3.75 equals the square root of h minus 36. So now there's two things still attached to my h. I have the square root and I have the negative 36. Well, the negative 36 is inside the square root, so I have to make sure I get rid of the square root first. So I'm going to square both sides. So I'm going to take 3.75 and square it. I end up with 14.0625 equals h minus 36. At this point, to get h alone, I just need to add 36 to both sides. So I have 14.0625 plus 36. I end up with 50.0625 equals h. Well, the question becomes, what is that 50.0625? Well, that is our height because this is feet per second and our diameter was 36 foot. The height then is going to be 50.0625 feet will be our overall answer, and we will be done. Now, on the bottom part of this note sheet, you have an opportunity to go ahead and design a roller coaster of your own using the same formula that we just talked about. Try to make it realistic if you can, or just have fun with it. See if something is even possible to make. Otherwise, that is the end of our note sheet. If you have any questions moving forward, please make sure you let me know. Otherwise, thank you very much for watching the video, and have a great day.